No theme music today. I was just at a close.
Break my stride?
No, there's no stride breaking. But I was over signing papers on the sale of my home, and it was like roll out, roll back. Very little time to. Very little margin in between, but I had to get it done, and that was my window. Okay, I've got the link. I'm doing my linky thing real quick. There's the link. Today's the last day, everybody. That's crazy.
Yeah, buddy.
Yeah, man. We had to get to this point eventually. I mean, either like the universe was going to end for us, or we'd get to this point, right? But the beautiful thing about college, whether you're a student or a professor, is that because it just rolls on this calendar, it just ends. Like cleaning your bedroom, maybe that never happens. But sucking at a class, it actually ends. That's crazy. And cool. And industry is nothing really quite like that either. Industry, you know what I mean? Projects aren't shipping until the code's done, until you're done building it, It's not like, well, I guess I just got a C- on that project, boss. It doesn't work like that. Okay, let me see. All right, streams are there, links are dropped. PowerPointo. Let's go find the PowerPoints. While I'm looking for PowerPoints to fire up and go the last leg here where we're going to talk about the stack. I did say before, I don't know if I posted an announcement, I probably didn't, about the fact that modules 11 and 12, I'm making a note to myself. Modules 11 and 12 you can submit during the finals week stretch, before you take them. All the others have to be done by tonight, the homework. And then I've already described how this week kind of just continues through. How do we do this? As of today, I guess. Zach, this one's a weird one. Or do we just roll through Sunday and then reset again Monday? Because there's always a point where we reset. You know what I mean? What do you think? Let me see. Zach, you on here? Yeah. I don't know. We oughta. Let's figure this out real quick. It seems like the timing's odd. It seems like in the past the semester ends and we just like go the rest of the weekend or something, and then next week finals go through the 18th, which is a week from Friday. So it doesn't matter to me, but there's a point at which we reset everybody and everyone's like green light go again, for the one last push. Technically, is finals week start Saturday or Monday? Because I think Friday's like what they call like a reading day, prep day. Any ideas? Am I alone on this voice chat?
Yes, the rest of us died.
You all encountered that end of the universe I was talking about. I'm looking up. I just want to. My original idea was, we'd be okay. We'd go through this week, and then we'd have next week, and it was all feeling nice and chunked out, happy. And now. Yeah, see, Fridays. No, we're good. We're good. I like this. I posted the schedule here, right? You should be able to see that on the screen. Tomorrow's a prep day. Then it's actually then there's the weekend, which is doesn't exist, apparently. And then finals actually start on Monday. So we're going to go with and keep it normal, okay? Where you've still got the end of this week through Sunday to do, any homeworks. And sanity check me, Zach, if I'm like making crap up that is like really stupid. That is distinctly possible.
So I have a question.
Yeah.
So you're saying only modules 11 and 12 can be turned in next week?
Ye-
Everything else must be done today.
Well, this is another question actually, because if we have prep day and the weekend, this is the question. You know what I mean? It always just seems like, I don't know, it just seems like in the past that the last day of the semester has been like a Friday, and then, you know what I mean, you've got that extra full day to, get the last project done or whatever. I don't know.
Well, I know we don't have a lot of projects yet, so
Yeah. Okay, what about this? I'm gonna go bold here. And I know some of you are sitting there going, go bold, go bold. Dr. K, go bold. Do not break your stride. Now is not the time to break your stride, Dr. K.
you take that little rowboat to China.
Okay, now let me stop. It's a lyric from Breaking My Stride.
Oh yeah, but what does that mean? Is it all?
Oh, what does it mean as a lyric? I don't know. I would not myself take a rowboat to China unless I was starting kind of nearby,
From say Taiwan.
Yeah, perhaps, exactly, something like that. Okinawa, something, I don't know. But here's the deal. The principle here is that during finals week, what you don't want to have is like big projects due, big stuff, where suddenly someone's like creaming themselves on some big paper and then prepping for finals, and the other projects are clogging up the rest of exam, preparation for exams. And I believe in that principle. It's consistent with the university. One of the rare times I'm actually consistent with with the university policy in terms of what I feel in my heart is really I believe in that. But if finals week doesn't start till Monday, it's sort of no skin off my nose to have stuff due kind of like end of the week. I don't know. So Zach, this is the part where you can sanity check me if I'm going off the rails here, like semi-publicly. I don't know.
So you would just want to extend that due date till Sunday?
Right. I mean, that would be the idea. Would just be like everything kind of regular. So that would be, finishing any of the homeworks, and the final project, and the large program, the large project.
I feel a disturbance in the force.
Is that a bad or a good?
Just cried out in joy.
and we're silenced. I think that's the rest of the line.
Yeah, I think that's how you.
I think it works. I'm just trying to make sure I'm not violating some other principle that I also hold. Yeah, I mean, there is that whole like prep for exams, whatever, but I'm good with that. Should we just do that Sunday night? I know what all of you are thinking on that one. No, let's go Sunday night, midnight. Okay? Make it so, number one. Sunday night at midnight is all homeworks have to be submitted except for 11 and 12. We're still going to go with that because that buys a little more time. 11 and 12 are not, they're not hard. Yeah, let's just leave what we were doing. All the homework 1 through 10 has to be done by Sunday night. And then on Monday morning, first thing, we'll do the reset. So there's no more homework that can be submitted except for 11 and 12. And then during that week, and it'll be Monday through Friday, that's finals week. Okay? Monday through Friday, you've got one last shot to either retake any exam you want or to take an exam that you haven't taken, but it's still only one shot per module. Okay? You can't retake module 5, 3 times. next week. We'll reset everybody Monday morning, and then you'll have one shot for every module. Okay, is that cool?
Sounds good to me.
I think it's reasonable, and I don't think it breaks anything else. That's the key, because I really don't want to be shorting, your prep in other classes for finals and what have you. Okay.
And this still means that the project is still due today.
No, the project as well. I didn't mention the project,
Okay.
but yes, project also Sunday night at midnight.
We're talking about the large program here. This new
Yeah,
Monday?
yeah.
Okay.
And along with all the homework for the modules, do you also need the exams as well? I mean, because I know we're going to be able to have a chance to have one more retake if needed next week, but do we need to take, let's say if we still need to take exam 10, then we need to get that done for the first time before Sunday?
No. Yeah, no. Incorrect. Happily incorrect. So basically, when we get into finals week, it's just like one more go. Your choice. It could be a first go. It could be a fifth go on a particular module. Whatever benefits you the most in terms of retaking to bump up a score or taking for the first time. You don't have to have taken any modules. Conceptually, I do not recommend this, but conceptually, you could have all the homeworks done, haven't taken any modules, turn the project in, and then, I shouldn't even say this, because someone's just going to be going, that's it. That's what I'm going for. But you could conceptually take all 10 exams next week. I don't recommend it. And if you really haven't done any by now, you're probably doomed anyway. You know what I mean? It's not going to end well. Okay. Zach, right afterwards, let's get the announcement out so everybody knows. Sound good? Problem is, I'm dying with, I got stuff I got to do for my other class with all the house stuff, and I'm a little frazzled. I'm a lot frazzled. Okay, my friends. I miei amici. There we go. Actually, I don't need to slide that over there. I'm a doof. Hang on a second. I just need to do that. Here we go, man. Here we go. This is going to be so easy. Seriously, this is fast and easy. So here's what I'm going to do. Let's go. We'll do the fast and easy stack lecture. Okay. Yeah, David, we saved you from yourself. And anybody who's like, oh, crap, man, I stayed up all night getting it done. Guess what? It's done. Congrats. You had to do that sooner or later, and you would have simply waited until Saturday night and stayed up all night. You know. I've learned over many years of being a professor to never apologize for, like, flexing a due date or being more generous. Because there's always somebody who's going to piss and moan about it. So I'm not worried. I'm not, yeah. Anyway, and I'm not, Ryan, I'm not accusing you. Let's be really clear here. I'm not accusing you of pissing and moaning about it. But it did like spark the thought, you know what I mean, that I've had these complaints. Dr. K, okay, listen. Okay. It's all good. Let's do this thing. So here's what we're going to do. We're going to talk about the stack. It's going to go fast. It's not complex. It's not a lot. Then with remaining time, and/or I can't really go over today because I just got everything's all backlogged because of the house thing. But we can answer any other like project questions, nagging, kind of like nagging help section questions, that kind of thing, right? Be kind of help section-ish, okay?
Roger.
Okay. Thank you. I needed somebody to give me like emotional permission to carry on, so thank you for that. I'm so ready to be done, and I know you are too. I know we're not alone. I'm not alone in my desire to be done. Are you ready? Yes, you are. Okay, let's do it. Dun, dun, the stack. Now, by the way, when you get into what comes next, 1410, after 1400, comes 1410, then 2420, you'll get into data structures in those classes, right? And you'll talk about stacks and queues and decks and linked lists and arrays, and you'll get a lot more into this idea of data structures, okay? It turns out that we're talking about, what's that?
And some of us already have.
And some of you already have, and it is really cool. Yeah, it is really cool. Well, what we're doing today is we're going to talk about stacks and queues, but mostly stacks. And the main reason that we're talking about stacks is that, why now? Well, really two reasons in my view. Three. The weakest reason is that it's what comes next in the book. But why is that in the book, right? And the answer is stacks are very important when you're doing low-level software, like assembly language. Most real instruction set architectures, like on the Raspberry Pi, for example, have stack operations, like a push and a pop, okay, which we're going to talk about, and have the ability to be able, you know how we have to take values and save them, right? Store them into a save spot and then load them back before we return from a subroutine or something. Well, another way around that is if there is a system stack or a stack that's available to the thread that's running, you can actually push and pop these things on to and from a stack. And it's very common to be like, I'm going to push register 0, push 1, push 2, push register 3. Then when I'm done, I pop register 3, pop register 2, pop register 1, and pop register 0. And that's an alternate way of sort of saving things away and pulling them back. Okay. So that's one of the big reasons, is that it is very common in assembly language to have push and pop operations. And really kind of very related to that, and very related to assembly language and low-level hardware stuff, is that when you do operating system stuff, system stack stuff becomes very, very important. So it's not just like, oh, I'm solving my little problem and I'm going to use a stack data structure. Stacks are one of those data structures that are very central to low-level system software and architecture. Okay, some architectures literally have stacks built in, like we have little registers and there's main memory and stuff like that. Imagine having a stack, as a little area built in to the chip, right? I mean, it's just so central that you see a lot of use of stacks when you get into low-level software. That's really the main reason why. So here's the idea. We sometimes call this a LIFO, last in, first out. I don't know. I don't like it. But it's more common that a queue is called a FIFO, first in, first out. But a LIFO, to me, it always makes me think of liposuction, which always seems like disgusting or something. I don't know.
Like LiFo batteries.
What is it?
I mean, it's just I don't remember exactly.
Lithium-ion batteries, often
Yeah.
abbreviated to litho.
LiFo.
Okay, litho. Okay, yeah, no, that works. Yeah, but I don't like the acronym anyway. So the idea is that you just have this stuff, and the last one you put on is the first one you're going to take off. Okay, that's it. And I'm going to show you some examples to illustrate that. When you put things onto the stack, you push them, and when you take things off the stack, you pop them. Okay? Push and pop. And then you're like, okay, how do we do overflow in this environment? Overflow means I've got this much space in my stack, and then I try to push something else on it. We're out of space. Underflow, the stack is empty, and I call a pop. That's pretty straightforward, right? Okay. I'm ignoring Mike. Here's some examples of stack data structure. Very loose, right? Stacks of plate, a stack of mail, right? Stack of Sorry, Chad. Once you pop, you just can't stop. Then you get to underflow. Stacks of pancakes, right? Now, the problem with this is that the metaphor doesn't really perfectly line up. You know, like, you know what I mean? You have the stack of plates, and you go to get a steak plate. Ideally, right, you grab the one off the top. Next person comes. You know those, like, push-down units at the cafeterias? Where, you know, it's like there's like a stack of plates, and they go down, and you take one off, and it, like, lifts a little bit. And you take the next one, it's gravity on a spring. The only problem with that one is that when they come rolling back with replacement plates at the Chuckarama or whatever, Pringles are stacked. And by the way, Chad, you don't pluralize with an apostrophe. No apostrophe. Pringles. Pringle S. You can edit that. I'll give you emotional extra credit if you do. But yeah, but these are all stacks, right? These are things that we know of as stacks. Okay. And the problem is that you know, if you do the Pringles, there you go. You can edit in Discord, by the way. You can edit your existing little chat post, like right mouse click on it, or actually hover on it, and then over on the right stuff appears. You know, you kind of touch it, and there's like a little triple dot that shows up. That's also a little Discord lesson as well. Let me see. I'm just trying to make the world safe for good grammar, you know, like one apostrophe at a time. The big problem is, you know, you come in and you just drop an entire stack of plates on. You don't really, these break down, right? You're looking for the mail, you start flipping through it. You don't like take one off, look at it, put it back on, you know, it's a stack, but it doesn't work like a stack. So this is, to me, the whole plates thing only works. I used to be a dishwasher long ago at a restaurant, not just in my apartment. But you know what I mean? You don't come in and go like, I put a plate on, I put a plate on, I push, I push, I push. You just drop the next little chunk, 20 at a time, and it just drops down. They take them off one at a time, but the metaphor breaks down. And pancakes, that's a big stack. But if I get a little stack of pancakes, right? You know what I'm doing? I'm going pie slice through the whole thing, so that breaks down. You know what I mean? You don't eat the top one. You know what I'm saying? It messes up. So I was looking like, okay, what's the best metaphor for this, right? Okay, Andrew, it actually says that it's stackable potato chips. Yes, potato-based chips. By the way,
It's only made from the base of a potato.
Lay's stacks, if somebody wants to drop a little of that on their STAX, they're actually called stacks, and they kick Pringles' butt pretty much. Just know that, okay? That the Lay's stacks, truth, my friend. Get used to it. Stacks. Lay's stacks. No, it's not subjective. You're wrong. Yeah. Subjective is where there's room for another opinion, Zach. Okay. All right. Here's a stack. That's a stack, baby, right there. Okay? You know these, right? You go to the grocery store, you get a grocery cart. It depends on, you know, it mixes up quite a bit. This is problematic in a bunch of ways, okay, right? So if you want to get a shopping cart, you have to take, now there's actually 3 stacks, fair, but you have to take one, right? Otherwise, you can't be like, I want that, you know, that one right there. You can, but you've got to pop, grab the one, and then take the other stuff and push. So you really do have to do all that, okay? When you return it, you push it back on. When you grab one, you pop. Okay, here's the problem. Anybody want to identify any of the problems with this from a cart management perspective? Oh, let's just go.
Put the carts that you popped off. That's a management.
What if you need something in the middle?
You can't have it in the middle. Yeah. What else though? What's practical? By the way, Ryan, let's just give kudos to regular Lay's potato chips, and you know what I mean. I'm done now with the chips. But you can't stack them, but they are really just, that's comfort food right there. No, but you ever got? I have this theory. It may shock you to know that I have a theory. you go into a grocery store, right? Why is it? Why? That like in every grocery cart, every grocery cart in America, maybe elsewhere in the world, but I know in America because that's where I live, there's always one wheel that goes, brrr, you take off, you go, brrr. Why? You know, or the whole thing just like the cart's just always drifts, you know what I mean? And if ideally you get it both, it's like, brrr, brrr, and then you're like, you're breaking your wrists, you know what I mean? Trying to like keep it from just ricocheting off the, you know? Why? My theory is that, I have a couple of theories. One has to do with just the fact that they travel around the parking lot and they get dragged all together with the helper dudes, whatever, that are bringing the carts in. But I think that one of the struggle, or the cart squeaks, I'm at a phase of my life, Stephanie, where I've lost the hearing in the upper registers, in the upper ranges, and so I can't even hear the squeak, so it's all great. No, the big problem that I've got with this is that how often does that, look at that cart way down there, that one way down, these guys down there, how often do they, am I bass boosted or is it just my confident voice? What did I do? What's happening?
So you're incredibly confident.
Is it my just confident voice? I haven't done anything, I swear.
Sounds normal to me.
Okay. Now I can bass boost in a world.
Let's not say we did.
That's not, yeah. Yeah, right. No, so how often does that guy get used? Way the heck down there. Right? It's got to, Caleb, it's got to be you, man. It's got to be, I don't know. If everyone's not hearing me bass boosted, it's got to be on your side. I don't know. Anyway, right, how often do those get used? This is my problem, right? On an average day shopping, I think that like that half of the carts aren't even going to get touched. They're just sitting down there, kind of brand new, and then these ones up here are just getting used nonstop. You see the kind of the inequity? You with me on this?
Carts in a queue than a stack.
Ooh, there you go. Now a queue, I don't even think I have a graphic for queue. And it's spelled Queue, because it comes from French.
UVU.
Queue. It's a strange word in English, but really...
It's just the letter Q followed by 4 silent letters.
Yes, exactly. The letter Q said as the letter, followed by 4 silent letters. Thank you, French. Thank you, French, for making this possible. The French language.
They're the worst. I know because I'm French.
Are you French?
Yes.
I can say they are the worst too. I know because I'm German.
Exactly.
Okay, all right, excellent. I can say that because I'm American, and I actually am genetically French, and I also speak French. But with a Q, what happens is, actually, maybe I have. Hang on. No, there are these shopping cart things. Who does this? Walmart. Walmart does this, right? Right? Who does it? Shopco? Costco? Yeah, right? Where they'll bring the carts in on one end, and the carts will move through. Who else does it? Smith's does it. You know, but basically the carts are moving through, so the carts are being more uniformly used, which I think is good. I think it's pleasing. But that's what a queue is, okay? In a queue, you've got some structure, some like landing area. Stuff comes in, and then it goes out. And the first one in was the first one out. Call it a FIFO. I more often see FIFOs called FIFOs than stacks called LIFOs. I don't know why. That's just an anecdotal observation. Okay, let's keep going. Here we go. Let's look at it as a data structure. Ready? This is our stack. We push the 2, we push the 3, push the 4, push the 5, push the 6. And then we pop the 6. Oh, how unsatisfying. We don't have a picture with the 6 on it. There's no like stable moment where the 6 is just sitting there. But you get the idea, right? I pop it off. The stack is now that. I pop the 5. That's what's left. You always have to pop from the top, and you always have to push onto the top. Pop off the top, push on the top. Now here's a you want a anybody want an exam question? I think this might be a homework question too, but it's an exam question, which asks you to describe in as much detail as you can push and pop operation. Okay? Really, there's two things that happens in each of those cases. When you're pushing, you have to adjust the stack pointer. There's a stack pointer that tells you where the top is. When you pop, that stack pointer, goes down. When you push, that stack pointer goes up. So the two steps are, when you're pushing, you got to put your thing, put that object, whatever it is that you're pushing on, and then you got to adjust the stack pointer. And we'll talk a little bit about the fact that from an implementation perspective, the stack pointer might point at the top, at the last item, or it might point at the empty space above it. They're both valid. They're both ways of doing it. Okay? If the stack pointer, like if I've got, I don't know, what's an example? Here's my stack. If my stack pointer is pointing at the last element, and I want to push something onto it, like my headphones, right? Then what I've got to actually do is increment the stack pointer and then put the object where I'm now pointing. And then just hold tight. That's if you're pointing at the last element. The other approach is where you're pointing above it. And now what you would do is push that object by putting it there and then increment the stack pointer. The only difference is whether you increment the stack pointer and then put the item, at that location, or whether you put the item first and then increment the stack pointer. But conceptually, it's the same. Same with pop, right? If I'm at this point, if I'm, how's it work? I think with pop, I have to be pointing at the last element, so I can remove it and then decrement the stack pointer. No, I can't. Nothing else really makes sense that I can think of at that point, right? Starting up here, you could actually. You would decrement the stack pointer and then remove the item at that location. And when I say remove it, I just mean make a copy of it. Conceptually, I'm removing it. In memory, whatever was there is still there. Okay, we talked about that once. Okay. Great stack improv, yes. Okay. Here's another one. Somebody else's graphic. I got to make better graphics for this. I really, really do. I'm disappointed in myself. Okay, so here's an empty stack, and I push the value 2. Boom, there's the 2. And in this case, the top, which is like the stack pointer, as we call it, is pointing to the top element. See how, right? Every time I push 5, I push 7, I push a 1. Now I pop, and the way I do this, I don't pop a 1 in the sense that I don't go pop paren 1. I just say pop. Return to me whatever's on the top. Hop on pop, pop on top. Dr. Seuss should have taught this lecture. But so you see that's why this just kind of goes pop, and then it goes, oh, here's the top element. It happened to be a 1. I didn't ask for a 1. I just said, give me the top element. But when I pushed, I had to give to you what the item was that you were going to put on the stack. I pushed 21, then I just popped, I popped, and I popped, and then this is the stack. You get the idea. This is conceptually very simple, I think. Let's do another one in a slightly different way, okay? We're going to conceptualize like an LC3 sort of stack. There's no stack in the LC3. But there's no like built-in stack. You could make a stack. When do you lock and drop? I think that's on underflow or overflow, Mike, is when you lock and drop. I don't know. Now, the stack is implemented in memory. These are just memory locations, okay? 3FFB, 3FFC, these are just like spots in memory that we decided to use. We decided to use R6 as our stack pointer. Right? I mean, you could use anything. You could use another memory location, but using a register is kind of handy. And that register has an address. Now, in this case, okay, one other thing I need to talk about. This process here, on this one, let me see. On this one, I showed the stack growing up and then shrinking down. On this one, the stack also grew up and is shrinking down. On this one, the stack starts up here and grows down and shrinks back up. It doesn't matter. As long as you get the math right, it doesn't matter. Okay? This one is kind of like this because we sort of said, okay, LC3, and we all know that in the LC3, the way we conceptualized it is the first memory location is at the top, right? 0, 0, 0, 0, and then 0, 0, 0, 1, 0, 0, 0, 2, right? And then it goes all the way down to FFFF, which is in the memory map. It's in the memory maps, okay? But it grows, the memory moves this way. So it's a little bit like that, right? So it's a little bit, this one you have to maybe look at and conceptually satisfy yourself about it, okay? Just try to remember, this is memory growing down. This is the stack pointer that we just decided to use R6. And R6 points at the top. Now, notice there's a couple things to notice, okay? One is that R6 is pointing to, like in this example of the stack, it's pointing to the empty spot above the stack. It points to where the object you're pushing is going to go. And you're going to put it there, and then you're going to bump it up, okay? Let's see. Another thing I just want to point out, these little hash marks here, these little, this is just notational. If I did these myself, these came from the book, but if I did these myself, I would probably do colors or something like that. They look a little bit like the end zone of the football field at Notre Dame. If anyone wants to drop a graphic of that on the chat, that would be cool. So you can confirm that I'm not like lying. But that kind of is what the end zone at Notre Dame looks like, Notre Dame Stadium. So, yeah, so here's our initial state, right? And the initial state, by the way, wait, hang on. Oh my gosh, I'm so dumb. I'm so sorry, I've misled you. The memory's going this way, but what you can see is that the stack is actually still growing up. I am so sorry. I lost track of that. So the stack is growing up, but actually going, there we go, but actually going, if you will, kind of like, it's like memory goes from 0 bigger, and the stack's actually moving this way as we grow it, which is almost like, I don't know. It doesn't matter, because you can implement it any way you want, but just understand that memory's going this way and the stack's going to grow that way. So all it means is you just have to do the math right. So let's walk through it. R6 is the top of the stack pointer. It's pointing at the first empty spot, okay? We pushed the value 18 onto the stack. So 18 gets put... Sorry. No. Man, I'm so confused. I'm not terminally confused. I'm just rolling off here, and then I'm gonna correct myself again. Can we start over? Can we just start over? I told you I was running.
Go back to September.
Let's start over. Let's go back to August. No, let's not. No, I'm sorry. It's the day and running crazy. The reason I'm correcting myself is because you can look at it and see. Okay. Branch to August. That has to be a BRNZP, I think, Chad, to August. Okay, so what's actually happening here is this is like, it's 4,000, but that would have to be like an indicator that says the empty stack. You know what I mean? If I tried to pop and the value was 4,000, I would know in my code that was, an empty stack. I push the 18, and what this has got to do is it's got to increment the program counter, then it puts the value, and then it just stays. So I was correct in that it's pointing at the last element, but the empty, it actually is going like below the stack. And that's the resting position for this thing. Okay? So I push the 18 in here, and then I have to bump the stack pointer up one, but I'm going, when I go that way in memory, I'm actually going -1, right? The actual address is -1. That's why 4000 hex turns into 3FFF, because I have to decrement the actual value here in order to move the pointer, okay? Wait, is that true? Thanks to, oh my gosh, no, seriously, this is not my day. No NZP, BR straight up.
Those are just equal to each other. BR and ZP and just BR. The assembler recognizes them as the same thing.
I just don't know if I'm buying. Well, then how do you use assembler to create BR nothing?
You don't.
You do a dot fill. You do a dot fill with the
zero.
dot fill 0, yeah, which is a no-op. Nice. Okay, we got that settled. Let me keep going. So then we push 31, and R6 gets decremented again, but is now here. And then we push a 5, and it gets decremented. It's here. And then we push a 12, and it gets decremented, and it's here. And now R6 is 3FFC. And then we go. Now we pop. We pop the 12, we pop the 5, and then R6 is now here. When I pop, in this case, I have to add 1 to R6. Then when I pop again, I add 1 again to R6. Now, some of you are going, when do I add and when do I not? And this is all so confusing. Right, okay, and the answer is don't worry about it. Like, literally, don't worry about it. First of all, when I'm asking you these questions on the exam, I'm going to try to ask you to describe it. Draw a picture, man. You can't draw a picture. You don't draw a picture. Do ASCII art as a picture. No, but talk to me about. Well, you can actually graphically. You know what I mean. You could do like dash 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 something dash dash dash. You could figuratively create. You could. I don't know. But you know what I'm trying to say. You can just kind of say, I got to increment the stack pointer. I'm incrementing or decrementing the stack pointer. Whichever way the stack is growing, incrementing is going in that direction and decrementing is going in the opposite direction. You don't need to remember, when R6 is 3FFE and then you pop twice and then you don't have to remember any of that. Okay? Now here's the trick question. Notice what's sitting right here. We overwrote these little hash marks, and then I popped again. 12 and 5, what are you doing? What are they doing up there? Hint, they're minding their own business. They don't, it's leftover. It's an artifact in memory. It's the way memory works in a computer. Right? I popped the value. I popped it off. When I ate the pancakes, the pancake wasn't still there. When I took the plate wasn't also still there. Well, guess what? In memory, if I read that value, right, I pop it, I read it, and kind of conceptually put it over there, well, its ghost image is still sitting there. We didn't, we don't manually go back and go, scrub that, unless you're like the NSA or something, or you got this hyper secure whatever, and then every time you do anything in memory, you're like scrubbing around behind you, and, things like that. But in normal code, you don't do it. So they're just still there in memory. It's not going to change. And by the way, Zach, I just had a really good idea. For once. First time today. Second time today. I had a really good idea earlier. No, but you could, you can build a push and pop instruction with trap instructions.
Is that your big idea?
Yes. Okay, look.
Yeah, you could.
Yes, thanks for that affirmation.
Increment your pointer and then do the pivot.
You could, no, but what you could actually do though, I think this is actually brilliant. You could implement a stack system with trap instructions. Call a trap to set one up and just tell it how big you wanted it. Right? And then call another instruction to push values onto that stack, right? To return the stack pointer. You could do all of that with trap instructions. I think it would be cool. Could be the next new cool project. Or not. Okay, let me keep going.
Slow clapping.
No clapping. What is the sound of one hand clapping? What is the sound of no hands clapping? This right here. Okay. Seriously. I need something really bad. I don't even know. I don't drink, so that's not an option. I need something, though. Okay, here we go. Here's an example of making our own little label that we call push and our own little label. This is just LC3 assembly, right? So I could do like go to push, right? And I basically take R6, I add -1 to it, and I put that back in R6. What I just did was I decremented the stack pointer. I decremented the value in there, but I incremented the stack pointer. And then I store whatever's in R0, if that's the value we're using, we do a STR with the register. Using R6 as a base register and no offset, I store that in. What else could I do? How could I do this if I wanted to flip the order and do the store first and then the add? What could I do? Bueller. Somebody knows. Somebody has an idea. If I said I want you to do that same thing, but for whatever reason I'm just a weird boss or whatever, and I'm just going to make you do the store instruction first, followed by the add. How could I do it? I'm going to wait. Oh, I can't hear you.
Like, could you put in the store instruction a number 1 instead of a number 0?
Yeah, exactly. Well, what I would need to do is actually go -1. Because R6 would, like in this case, it would be 4,000, but I need to put the value in 3FFF. So I could go store R0, R6, and then the literal -1 right here, right? And it would just simply reference the spot of conceptually above the stack pointer. And then I would still have to decrement the value in R6. But see what I mean? I could use the offset, in other words. I could use this offset. Anyway, same thing with popping. I do a load R through R6. R6 is the base register. No offset. Right? Grab whatever's there, put it in R0. And then add 1 to R6, which decrements the stack pointer when I add 1 to R6. Cool? You know it's cool. Okay, let's do some math. This is going to be easy peasy. Let's look at this. We already know how to do this one, right? Assume that, whatever, there's some, let's just say there's some function, whatever, you know. But let's take a look at this. I put some dot fills here, A, B, C, D, and then this block word, which just allocates a spot. It just blocks out that spot, calls it E. And what I'm going to do is E equals A plus B, that quantity, times the quantity C plus D. So what do? Right? Now, and I'm assuming right there, see that mul? I'm assuming that we have an instruction called mul. Okay, we don't, but assume we did. I'm going to take the value, I'm going to load A into R0. That's a dot fill with the value 25, literal 25. And that is a decimal 25. Then I load R1 with 17. I add those together. I add R0 and R1, and I just put it back into R0 for now. I grab C, I grab D, which is 3 and 2, right? I add those together, put that back into R2. Now I've got R0 is this first quantity, this first sum, and R2 is this sum. Now I want to multiply R2 and R0 right there. And I call the mul. And I put the result in R0, then I store the value of R0 into this location allocated by E. By the way, there have been a few questions about block W. One of the questions might be, can I just do like dot fill 0 instead of block W? No. Block W allows me to allocate a whole bunch.
If you were doing block W1.
Yes. If I was doing block W1, that in that statement I could replace with dot fill anything, right? Because I'm going to overwrite it, but let's just say 0 for convenience. But the problem is that that's not the value of block W. Block W is like, I need space for the input string on that final project. 80 characters ought to do it. Block W pound 80, and I just, in the symbol table, I just bumped the location counter 80 spots. So the next line of code is referring to 80 away. Okay? That's what it means to like allocate 80 spaces. Okay. But we know how to do that, right? That's all good. But imagine we were going to do it with a stack-based language. Or just simply using stack operations if our language had stack operations. Right? What are we going to do? So let's walk through this thing, and we'll use this little cool animation with the stack pointer. I'm going to push 25, right? Then I'm going to push 17, and then I'm going to do, and we all know how that works. Now, an add instruction, even in a stack world, is a binary instruction, meaning it takes two operands. So what it does is it pops the first one. It pops the second one. It performs the operation, it takes the result, and pushes the result back on the stack. Okay? Like so. 42, which is the answer to the ultimate question of life, the universe, and everything. And now that's just sitting there, and that's what the stack pointer is. Now, I've got A plus B hanging out. A plus B is right there. Now what I do is I push the value 3, I push the value 2, and I'm going to do an add. That's going to take 3 plus 2, pop the 2, pop the 3, add them together, get the 5, push the 5 back on. Boom. Okay, pushes that on the stack. And now I've got this sum is sitting on the stack, and that sum is sitting on the stack. And they're just sitting there, and the multiply does exactly the same thing as a binary operator, okay, as a binary instruction. It's going to pop the first one, pop the second one, and multiply them together, and push them on the stack. Boom, 210. And now I can pop that value, whatever. Like, this is like FACO syntax, right? So I don't care, like, where does it go? Don't care, I'm just popping it. It's conceptual. If this were a real assembly language, I would have to designate like a register to, when I say pop from this whatever, I've got to give it a destination, where do I want that to go? Okay? There we go. And the stack is back to empty. Now, are you ready for something staggering? How about that? Gasp. Gasp to you, I say. That is the last slide of the semester. I told you that was short. And we even got 19 minutes to spare. It's a very short one. Okay. What's that?
Did you already cover the queue?
Yeah. There's no slides for the queue, because I'm a doofus. But let me throw another question at you, and it's an exam question. I'll just give you a little cheat on the exam. It's not cheating, because I'm telling you. But the question is, when are you going to use a queue, and when are you going to use a stack? What are some real-world examples, and then what are some computer examples?
The exam being the test.
The module exam, yeah, like the module 12 exam, yeah. going to ask you to talk about kind of queues versus stacks. What do you think, right? What do you think? Let's go real world. Queues versus stacks. And you can't use shopping carts. You can on the module exam. I mean, you know what I mean? If you can talk about shopping carts going on as a stack and what the downside of that is, and then as opposed to queues where they're going to move through. But apart from that, what do you got?
One thing that we come up with in another class, I think it had to do with something with like either a online retail store or a shop or like a library when you're checking out.
Okay.
You check out the user who enters in the queue first would be the first to have their order processed.
Oh yeah. You ever seen a sign in a store that says "first come, first served"? Right? What is that? That's a queue. Basically. Yeah. And in fact, in the UK, in America, we get in line, right?
They queue up.
They queue up. They get in the queue. So in the UK, regular lines, like a line at the grocery store, a line at the register, they call those queues. Okay. So any of those kinds of, yeah, right. So Chad, what would it look like if you had a restaurant, that had like a line that was a stack? I don't even know how you would do it. It would be bad though, right?
It'd be terrible.
No, I got it. This actually happened to me. I was at a Taco Bell. I was at the food court at BYU. And I was just in line, right? So in this queue to do the thing. And then there's a part, so that's a queue. It's a queue to order, right? Then your food goes into the system, and it's kind of a queue. You know what I mean? Maybe it's not perfect. They might be doing like 3, whatever they call, whatever, what were the Mexi fries, might have been like 3 orders of those come out at the same time. Or it's not purely a queue back in the back, right? But they're coming off, but mostly they're coming kind of in order.
Tacos as an order is easier to make than a Crunchwrap Supreme, so that might come out first.
That's right. So it's not perfect that way, but there's still. But the problem is that if you study queuing theory, which is actually a field, and it's actually pretty cool. But basically, what's happening is there's like a Crunchwrap, station and a taco station, and the order gets kind of split into different queues. So the first Crunchwrap ordered is going to be built before the second Crunchwrap order filled. But if it takes you longer to make a Crunchwrap, a taco ordered after that Crunchwrap might pop out in the order before it. See what I mean? So it's like you parallelize into different sort of service queues, and then you recombine